Does that? I'm still reviewing the stuff. Thank you, Mazen. Right, so we want to find the present worth of the net cash flow at the MAR value. And then we find the net present worth, basically, which means that I take all of my inflows. Sorry, this is diagonal, right? I take all of my outflows. I mean, maybe I have at some time periods, right? I have a net outflow. I move them all back to time 0. And then I add and subtract, of course, according to the direction. And usually it goes inflow minus outflow. That's how the net present worth is defined. So I'm going to move all of my inflows to time 0, move all of my outflows to time 0, right? I'll just draw another one here. And then when I find my inflow, I find my outflow, I subtract them, and that gives me the net present worth or the net present value. So sometimes we'll write this as NPV at time 0. And then based on that, I can determine whether or not to accept the investment or to reject it. So if the net present worth is positive, that means I accept the investment. If the net present worth is negative, that means I reject it. And if it is 0, that means I'm indifferent. And so like this is what the principle of this approach is to compute the equivalent net surplus. So this is another word. So a surplus is like inflow minus outflow at time 0 for a given interest rate I. In fact, I mean, we refer to this as the MAR in this context. And again, we accept the product if the net surplus is positive. So this is, I think, where we stopped. And so now we're going to see some examples on this. So here you move the inflows back to 0, and see that's what's happening here. You move the outflows back to 0, you subtract, and then you find the net surplus. And if it's positive, that means you go ahead and you accept the investment. So here's an example. Suppose you're given that a company's MAR value is 15%. How do we find the net present worth? Well, I'm already given sort of net cash flows here. I don't need to like do most of the steps that are in between, right? So some of these steps are for computing inflows, then outflows, and then net cash flows, which are inflows minus outflows. And in this case, I'm actually just given a net cash flow. Like these are the amounts that I'm given, just net. So I don't need to do anything there. What I need to do now is I need to take all of these payments and move them back to 0. Right, and I need to add and subtract accordingly, right? So everything here is income, except for this first one. So I need to be careful. I need to subtract it, right? And so of course you do these as well. And so here's what this looks like. And of course I need to move them back. What is my I in the formula? So, right, so I need to find a P given of an F value, right? And so here the exponent is negative because I'm moving back. What is my I value? Well, my I is going to be the MAR, which is going to be 15%. Right, so this is similar to what we've done before, and hopefully you all are comfortable with this. Okay, so I need to move this payment back, and so that's what's happening here. I'm moving it back. So I'm finding P given F for this payment at 15%. Of course, I'm moving it back one time period, which is why you see the 1 here. Same thing for the second payment, except now I move it back 2 time periods. For these payments, although the diagram, for some reason, at least to my eyes, these 4 lines here, or 4 tips, do not seem on the same level for some reason, but they're really equal payments. Like if you go back to the table, these 4 are equal payments. And we've seen how to handle cases like this. Like I can move them individually one by one. That's completely fine. It will give you the same answer. But I can recognize that this is an equal payment series, sort of this block. And we've seen this in chapter 2, so I don't need to spend too much time on it. And I can compute the present value of these 4 payments here at time 0. Right? And then I can take this and I can move it back. Of course, I may want to draw the arrow pointing up. It's just a force of habit that I draw it pointing down. But just to be careful and to understand that this is income, I'll draw it pointing up. Okay? So I need to find the P for these payments here. And then I need to move it back and find a P here. So I do it in kind of in 2 steps. And so that's what you see here. You take the equal payment series. You first compute the present value of this equal payment series at 15% and for 4 years. And remember, it's always going to be 1 time period before the first payment. So it's going to be at time period 2. And I needed to move it back after that for 2 time periods. Okay? And I also need to move this last payment here to time 0. And I find the net present, or I find, sorry, the present value of the income or of the savings. Because this is savings, right? This is for the same example that we talked about the machine shop, right? So the values given were in terms of savings. What I also need to do is I need to compute the present worth of this, the present value of this payment here, which is my outflow, my investment cost. But it's nothing other than the same value because I mean it's already at time 0, so I don't need to do anything with it. All right. So now I have my inflow, I have my outflow. I can just subtract my outflow from my inflow, and I find that the final value, the net present worth at 15%, is positive. That means I can accept the investment based on the net present worth criterion. All right. So this is very simple, very straightforward. Hopefully, it's exactly what we've seen before. What I can do as well is I can say, hey, how sensitive was my decision? So notice here that the net present worth and all of these present worths are functions of I, of the MAR value. Okay, so if I change my I, if a company changes the interest rate it's using to make decisions, I can ask the question of how will my net present worth change and how will my decision to accept or reject the product change? And so that's what's done here in this table. So I vary I in increments of 2 in this case. I mean, you could do it for whatever values you choose, but here they do it for increments of 2. And so notice that our 50% that we had in the question is somewhere in between here. And in fact, the value is actually somewhere in between. So it's 1,500, not 1,500, 1.5 million, whereas here it's 1.4 and 1.6. So that makes sense. So our value that we had in the question is somewhere here. But in any case, of course, as you increase the interest rate, you're discounting money more heavily, which means payments in the future are going to be worth less and less, right? And you can see it from the formula. If you just think about it from the formula, you can see, right, because you're multiplying by this, basically, which means you're actually dividing by this quantity here. And of course, as you increase I, then you're multiplying by a smaller number, and so that's why the values go down, okay? And so this kind of makes sense. And if you keep varying the interest rate, you see here there's a point at which the net present worth flips from a positive value to a negative value. And so you can actually find, I mean, you can use GoldSeek, for example, in Excel if you want to, or use, I don't know, Wolfram Alpha, whatever you want, to search for what this value is. The value of the interest rate that will make the net present worth equal to exactly 0. And if you do that, you actually find that the result is 36.32%. Okay, remember our MAR and the problem was 15%. And so let's see on a graph how these two values relate. So this thing here is sometimes called the break-even interest rate or the internal rate of return, which I think is sometimes abbreviated. I think we're going to see this later, this internal rate of return business. We sometimes abbreviate this as our IRR, right? So IRR is the internal rate of return, which means is the interest rate that makes the net present worth equal to exactly 0. And so on a graph, this is what things look like. So my present worth is a function of I, right? So that's why I'm plotting the present worth against I. And I'm varying the value of I. And I notice here that at 15, right, I get the value that we've computed before in the first part of this example, which is the roughly $1.5 million dollar figure. And we saw from the table that the present worth decreases as I increase the interest rate. And in fact, here, this is the point at which the net present worth is equal to 0, and that is the internal rate of return, or the break-even interest rate, right, which is 36.32%. And in fact, we'll see, I think later, or maybe you can see it from here, that because our MAR value is less than IRR, this region here corresponds to a region in which we accept the investment. Why? Because all of these, the values for the curve in this region are all positive, which means my net present worth is positive, and I know if I'm in that region, then I need to accept the investment, or I should accept the investment. Of course, if you go into this region here, then things become negative, right? And so in that case, you should reject the investment. So this is sort of the region of the graph where I accept the investment, because in that region, my net present worth is going to be positive. Yes, Mazen?
Yes, there shouldn't be the region between the IRR and MAR, not before IRR only.
So MAR is it can vary, right? So MAR, I mean, we're going to talk about this a little bit later. MAR, like a company has to estimate or decide what MAR to use. Okay, so MAR is not necessarily a fixed value, and so let me erase this stuff here. If a company estimates its MAR at 15%, this is its net present worth, and so it is positive, so it will accept the investment. But if it varies the MAR, if it estimates the MAR at 5%, then again, you go up here, you see that it has a positive value, right? I mean, roughly, that's what I'm kind of drawing, and therefore you also accept the investment. So any MAR value in this region is where you accept the investment. Okay, so not necessarily just here, because I mean, the value can be lower, but it will still have a positive net present worth. It just depends on how the company will estimate the value.
But
Right,
Doctor,
and that, yes.
Based on this graph, I can see that the lower the MAR, the better the investment is. Is that correct, or?
Yes, you can think about it that way. The more profitable the investment is, yes.
But why are they restricting themselves with MAR if they reduce it, it will benefit them?
So MAR, they can't just decide on a MAR arbitrarily. So they will try to estimate it and set it. And actually, that's what I'm going to talk about next. Like in the next slide, that's what we're getting at. So MAR depends on the project that you're undertaking. And so there are a few factors that go into this MAR. Right, and so a company will, depending on its risk level that it's willing to accept, depending on inflation, things like that, it will have to factor those into its MAR computation. So they can't just decide, well, oh, I set my MAR at 15%, and okay, it's more profitable for me. They have to still try to accurately estimate it based on a couple of things that we will see together, based on a variety of factors, based also on how much are they currently earning. So if this money that they're committing to this project is sitting somewhere in the savings account and it's earning interest, let's say at 15%, then that's the MAR that they are going to use, right? They're going to use that 15% or a value that is very close to it, because they're already, if they even do nothing, they're already earning 15%. So they're not going to choose a MAR of 5%. They're going to choose a MAR of 15%. And we're going to see more about this. We're going to talk in detail about how to choose or how to estimate this MAR, at least like how in general companies do it. Usually in problems you will be given a MAR value, and they will say the company's MAR is known to be 15%, but it's beneficial to understand where this value is coming from. And so hopefully that kind of, even though not fully, maybe it kind of answers your question, and we'll see together what goes into this MAR. In fact, like starting from the next slide. Okay, so let me erase that. So this is what I was hinting at. So think about it this way. In your own life, right, in your own investments, if you want to invest in, let's say, a stock market versus you want to invest your money in a savings account, etc., there's a minimum attractive rate of return for you, right? You look at different savings accounts and you say, well, if a savings account is just giving me 1% or 0.5% per year, you immediately know that it's not worth your time, because inflation alone may be at, let's say, 3%. So if you're just earning 0.5%, of course it's better than nothing, but it's not really worth it in that sense, because it's not, if there are better options, if there are other options that give you, let's say, 4 or 5%, then you're better off choosing those options, right? And so that's from your own personal point of view, but you can also think about it like, if you think about it, companies do the same thing, because depending on the investment that companies need to get involved in, they have to set a MAR such that it accounts for these three factors mainly. What are these three factors? The first one is inflation. That's the easiest one to see. My MAR, my interest rate, the rate of return that I want out of a project has to at least beat the inflation rate, right? And so that means if inflation rate is 3%, I should look for investments that give me minimum 3%. Like that's my starting point, for example. So I need some compensation to account for the loss in purchasing power due to inflation. I also need some risk-free return, right? So I need to say, hey, I know I will be getting this without any risk. So I will be getting, so out of, like after I beat inflation, I will need maybe an additional, let's say, I mean, this you can, it depends on like the product, depends on how you set it, but maybe I want an investment that gives me 4% risk-free return at the very least. This is sort of my baseline, my minimum attractive value. So now you have 7%, right? So this is my MAR, my personal MAR, if this is a personal project, is now set at 7%. And then you add the last factor, which is your risk premium. And so this depends on the project. So with stocks are riskier. So personally, you may set a very high percentage as your risk premium. So you say, I will not get into the stock market unless, because it is risky, unless I get like a return on my investment worth 20% on top of these values, for example, right? So I can say maybe in this case, in my example, I can put 10% here because I'm entering a risky investment. And then I can add all of these up to find 17%. So this is kind of my MAR value based on these three factors. And companies do the same thing. So I'll just wrap up this point so we can end here. They consider what sort of investment they're undertaking, how risky that investment is, what is the inflation rate, how much return is risk-free, and they add these up. And so these are kind of the components that go into the MAR. And you see here for a risky investment, because of the risk premium is high, and risk premium depends on the person. For some people, the risk premium may be lower, your risk premium may be higher. It just depends on you. And they add them up and they find 26%. Now, for a more stable investment that's not as risky, like with US bonds, you don't have a risk premium because they're not risky. You're going to get paid by the government. Like you have to go back to what bonds are if you've forgotten. And so here you see here there's a risk-free return, which is just 2%, and inflation is 4%. So the MAR for this project is at 6%. So you just add the two up. Okay, we're going to talk a little bit more about MAR and how we can interpret it to understand what's going on in the next class. And hopefully we can wrap the chapter up in the next class, maybe. If not, we'll wrap it up at the beginning of next week, inshallah. So I'll see you then. I'll take your questions after I stop recording. Thank you.